example where there is a lift. This is an elevator which can move vertically up and down, and this elevator is going with 5 meters per second square in the upward direction. And from the roof there is a pulley which is hanging. The pulley is massless. All the things, they are idle, that is strings, they are massless, they are idle strings. And we have two masses, 5 kg and 20 kg, connected to each other with a string passing over the pulley. We are supposed to find the accelerations of these two blocks as seen by a person on the ground. So this is the question. Now we shall try to solve this question both ways, using inertial reference frames and using non-inertial reference frames. When we say inertial reference frame, it means it is non-accelerating frame. So the person is over here. So we shall be solving this question from point of view of this person, and then we shall be having an observer, that is who is in the lift accelerating upwards with 2 meters per second square. That is, we shall be writing the equations with respect to, that is, taking this lift as an accelerating frame, as a reference frame which is accelerating, or we can think of that there is some observer who is moving with the same acceleration as that of the lift, and then he writes the equation. And then we see whether the two answers they match or whether they all together mean the different things. First, let's try to understand the triangle law of vector addition, how it can be applied in such a case. This is a person on the ground, and suppose this is a lift. Lift is going up with, let's say, 3 meters per second. And in the lift there is a person who is stationary with respect to lift. And then this person is raising an object in his hand with a velocity of 4 meters per second with respect to himself. That is, with respect to himself or with respect to lift. It's one and same thing. So what is the velocity of this object as seen by this person on the ground? So now we see that his lift is going 3 meters per second in the upward direction. And this block is moving at a speed of 4 meters per second with respect to this person in the upward direction. So the velocity of this block as seen by this is cumulative of this and this velocity, that is 3 plus 4, 7 meters per second. This is the velocity as seen by a person on the ground. This is something like, I have a block in my hand, I am in an elevator. You are on the ground. You can see me through this glass lift. This lift is going with 4 meters per second upwards. Suppose this block is stationary with respect to me and with respect to lift. So what's the velocity of the lift? The same velocity is of mine, and the same velocity is of this block. So if the lift is going up with 4 meters per second, you will see from ground that this block is also moving in 4 meters per second in the upward direction. But if I raise this with 3 meters per second, that is with respect to myself, I am pushing it up, moving it up with 3 meters per second. So obviously the velocity you will see from the ground is 4 meters per second, my velocity plus this velocity gets added up, that is 4 plus 3, 7. And in case I am lowering this with a 3 meters per second in the downward direction with respect to me, I am lowering this with the 3 meters per second velocity with respect to me, then what happens is 4 meters in every second the lift has taken me up, 4 meters the whole thing goes up, and then this comes down to 3 meters. So ultimately it is seen to be going up with 1 meter per second in the upward direction. The same thing is applicable for the accelerations also. Suppose the lift is going up with 3 meters per second square in the upward direction, and I am lifting a block with a 4 meters per second square in the upward direction. So acceleration of this object as seen by a person on the ground is 3 plus 4 is equal to 7 meters per second square. But if the lift is suppose going with 3 meters per second square in the upward direction, and this block is lowered with respect to lift with 4 meters per second square in the downward direction, so plus 3 minus 4, that is minus 1 meter per second square. That is, a person will see the acceleration of this object as 1 meter per second square in the downward direction. So if we talk about the triangle law of vector addition, it means that is, if this is a person on the ground and he wants to see the velocity of this block, velocity or acceleration, any vector it could be. So velocity of the object as seen by this person on the ground is what? Is a vector sum of velocity of this lift, or you say observer, the same thing, velocity vector of this lift plus velocity of this object with respect to this person. because it is all in the one direction, that is along the y-axis only. So what we can do is we can take the velocities in the upward direction as positive, in the downward direction as negative. So we say that the resultant velocity or net velocity of this object as seen by this is vector sum of this vector plus this vector, this velocity plus this velocity. Now what is the velocity of this? This velocity 3 meter per second in the upward direction. And what is the velocity of this as seen by this is 4 meter per second in this direction. So both the velocities, this is also plus 3 in the upward direction, and velocity of this also as seen by this is 4 meter per second in the upward direction, that is positive. So velocity of this as seen by this is plus 3 plus 4, that is plus 7 meter per second. Had it been the acceleration, suppose this is lift is going with 3 meter per second square in the upward direction, and this block is moving with 4 meter per second square with respect to the lift, or with respect to this person who is stationed with respect to lift, is one and same thing. So the acceleration of this block as seen by this person is the acceleration of the lift plus acceleration of this block with respect to lift or this observer, because this lift or this observer is one and the same thing. That means the same thing. So the acceleration of this block as seen by this person is acceleration of this lift, that is 3 meter per second square in the upward direction. So it is plus 3 meter per second square, plus acceleration of this with respect to this person on the lift, that is plus 4 meter per second square. So 3 plus 4, 7 meter per second square is the acceleration which is going to be seen by this person of this block. If this person is moving this block downwards with the acceleration of 4 meter per second square, so the acceleration of this person as seen by this person is plus 3, that is the whole lift is going up with 3 meter per second square, plus acceleration of this as seen by this, that is 4 meter per second in the downward direction. This plus this is equal to this. So this is plus 3 meter per second square, this is plus 3 meter per second square, and acceleration of this with respect to this person is 4 meter per second square downwards, so it is minus 4 meter per second square downwards. So the net acceleration of this block as seen by this is plus 3 meter per second square plus minus 4 meter per second square is equal to minus 1 meter per second square. That is, this person will see this block accelerating in the downward direction with 1 meter per second square acceleration. Now let's use this concept in this case when our observer is over here on the ground. When the lift is going up with 5 meter per second square, then let's say that is with respect to lift, that is if there is a person in the lift, or with respect to lift is one and same thing, 20 kg, 5 kg. So this person will see, or the lift with respect to lift, this block will go down and this block will go up. This is our constant length string. So if this goes by 1 meter, this will go up by 1 meter. Whatsoever is the acceleration of this in the downward direction, the same is the acceleration of this in the upward direction. Generally the students get confused, that is how to solve these questions, because it may happen that suppose this acceleration is very huge, then and the difference between these blocks is very small, then it may happen that is all the systems, all the blocks, they are virtually going up, they are going up with some acceleration with respect to this person. So how do we know that which block will come down, which block will go up? Which block will have an acceleration in the upward direction, which block will have an acceleration in the downward direction? This is very simple. The first thing what you have to see is, that is one basic thing, that is with respect to lift, you have to find that is which block with respect to lift will come down, which will go up. This is heavier, this will have acceleration in the downward direction with respect to lift. This is of lighter weight, so this will go up with the same acceleration. So with respect to lift, if it has an acceleration A downwards, then it will have an acceleration A upwards. That is the basic thing which you have to stick to. Then rest is very simple. It is very, very simple. Then what you do is, if you have to make the equations, then we shall be using the same concept over here. Let's see how. Onto this, draw the forces. This is T, this is 15 Newton, right? Onto this, this is T. In the same string, tension is same and tension is always outwards away from body, and this is 200 Newton. Now thing to be observed is, that is acceleration of this as seen by this and acceleration of this as seen by this is going to be different. It is not going to be same. acceleration of this and this with respect to lift is same, but the acceleration of this and this as seen by this person is going to be different. To understand it, let's say this is going with 2 meter per second square, A is 2 meter per second square, so this person will say its acceleration as 5 plus 2, 7 meter per second square. Whereas if this is going with 2 meter per second square, if this is going 2 meter per second square with respect to lift, so this will go down with 2 meter per second square with the lift in the downward direction. So its acceleration as seen by this is plus 5 minus 2, that is 3 meter per second square. Of this seen by this had come as 7 meter per second square. This 3 etc. we have just taken to understand the concept. We have to find the value of A. Actually right now we shall be finding what is the value of A. So the point to be noted is, that is with respect to this lift, both these blocks, they will have the same acceleration. One will be coming down with some acceleration and the other block will be moving up with the same value of acceleration. Whereas the value of acceleration as seen by this of these two blocks, that will be different. We have taken upward direction as positive, downward direction as negative. Suppose this is going down with the acceleration A and this is going up with the acceleration A. So now what is the acceleration of this block as seen by this person? A is the acceleration of blocks with respect to lift. This is to be noted. A is with respect to lift or with respect to this reference frame. So acceleration of 5 kg block with respect to this is acceleration of lift plus acceleration of this, that is 5 plus A, that is plus A plus 5. That is both the things they are in that direction. So let's make it as this is also plus A and this is plus 5. So this is plus A plus 5. Whereas acceleration of this as seen by this person is plus 5 minus A. So this is plus 5 minus A. This is a thing to be noted. That is, in the upward direction we are taking the vectors as positive, in the downward direction we are taking it as negative. So this block is moving with the acceleration A in the upward direction. Lift is already moving with 5 meter per second square in the upward direction. Acceleration of this block as seen by this is acceleration of lift plus acceleration of this block with respect to lift, that is plus 5 meter per second square. Lift is going up. With respect to lift, this is going with A meter per second square. So this is plus 5 plus A plus 5. That is the acceleration of this block with respect to him. Acceleration of this block is 5 meter per second square plus, that is it is going down, plus 5 minus A. That is acceleration of this block as seen by this person is acceleration of lift. What is that? That is plus 5. And with respect to lift, this block is going down with the acceleration A. Going down means negative. So plus 5 minus A, that is the acceleration of this block as seen by this. So he is going to write the equations now. That is, we are solving this question using the inertial reference frames or non-accelerated reference frames. So if we make the equation for this block, so upward is T is upward. So we say that is, we intend to apply F is equal to ma. That is net force is equal to mass into acceleration. What are the forces on acting on it? That is plus T in the upward direction plus minus 50 in the downward direction is equal to mass. Mass is what? 5. What is the acceleration of this? Acceleration of this is 5 plus A. That is, we have found it. That is acceleration of this as seen by this is 5 plus A. So this makes T minus 50 is equal to 25 plus 5A. This is equation number 1, we call it as. So let us see what is the force on this block. Onto this block, there is a one force plus T in the upward direction, and the second force is minus 200 Newton is in the downward direction. Both these forces, they were vertical, so that's why it was easy. That is plus T in the upward direction, minus 200 in the downward direction. We could have also on an inclined plane also we can solve the question using vectors, the same method. The only thing is then I and J unit vectors, they will also come into play. So over here, plus T plus minus 200, this stands for the resultant force onto this block is equal to mass. Mass of this is 20. What is acceleration of this? Acceleration of this is plus 5 in the upward direction, and then it is coming down, that is plus minus A. That is triangle law of vector addition. So this makes T minus 200 is equal to mass is 20 into 5 minus A. This is second equation. We can solve these equations. So this comes out to be T minus 75 is equal to 5A, and this will be t minus 300 is equal to minus 28. We can subtract this from this, so minus plus t minus t 0. So this comes out with 225, 300 minus 75, 225. This is 25 into a. So a comes out to be 9 meter per second square. So what is the acceleration? This is the acceleration. Now what is this value A? A is the acceleration of these blocks with respect to lift. So what is the acceleration of this as seen by this? As seen by this, acceleration of this is, what is the acceleration of this is A plus 5. That is plus 5 plus A. That is plus 5 plus 9 is equal to 14 meter per second square. That is, this person will see this block going up with acceleration of 14 meter per second square. So if the acceleration of these two blocks is 9 meter per second square with respect to lift, so it means the acceleration of this as seen by this is 5 plus 9, that is 14 meter per second square, is the acceleration of this block seen by this, and acceleration of this block as seen by this person is 5 is upwards, 9 is in the downward direction. So it is plus 5 plus minus 9 is equal to minus 4 meter per second square in the downward direction. So this person will see this block going down with the 4 meter per second square, and this person will see this block going up with 9 meter per second square. Now we will solve the same question using the accelerating reference frame. That is, when our observer is there in the lift and he observes, and in addition to all the real forces we know, then he will use a pseudo force, and we'll see that is the results, they should match with this result. Let's solve the same question using an accelerating reference frame or non-inertial reference frame. So it means our observer who was on the ground, who was making it as an inertial reference frame, let's say jumps and places himself in the lift. So lift is going up with 5 meter per second square. So this person who is stationary with the lift is also accelerating with 5 meter per second square. So this makes an accelerating reference frame. So if he wants to make the equations, if he wants to see the acceleration of these two blocks, one thing is sure, that is in the lift, this pulley is there. He will see that this block is going down. This is a heavier block. This will go down with the acceleration A, and he will see that this block goes up with the same acceleration A. So whatsoever acceleration this comes down, the same acceleration, this person will see that this is going up. We have to find what are the accelerations. So first thing is, let's draw all the real forces. He will have to draw all the real forces which are being applied on the blocks. So we know that is, this is one string. In one string the tension remains same, and tension is always away from the free body. When we are talking this of the free body as free body, then the tension is outward in this direction. When we are talking this as free body, tension is outward, that is, tension is in this direction. Throughout the string, this is massless ideal string. No extension, no mass, so tension remains same. The other forces which are acting is weights of these two blocks. We are taking G as 10 meter per second square. Weight is, downward pull is m into G, mass is 20, G is 10 meter per second square. So this is 20 into 10, that is 200 Newton is the force which the earth is applying in the downward direction, that its weight. Earth is also pulling it down with the force mg, that is 5 into G, that is 50 Newton in the downward direction. Now these are the real forces which are acting. Our reference frame, this person, this observer is making an accelerating reference frame. So the condition so that this accelerating reference frame can apply is competent to apply laws of motion. So in addition to all the real forces, he has to add one more force which is called pseudo force, fictitious force, imaginary force. This pseudo force, obviously the force is a vector quantity. It has got magnitude also, it has got direction also. The direction of pseudo force is opposite to the direction of acceleration of the accelerating observer. This observer is accelerating in this direction along with the lift. So he will apply a pseudo force onto this block in this direction. He will also apply a pseudo force onto this in this direction. Please note that is the direction of pseudo force is governed, is determined by the direction of acceleration of the observer. He is accelerating this way, so these blocks, they may be going anywhere. He will apply a pseudo force in the downward direction because he is accelerating in the upward direction. So the value of this pseudo force is mass of the block and acceleration of the observer. Mass of the block is 20 kg and acceleration is 5 meter per second square. He is going along with the lift. So 20 into 5, that is 100 Newton. And the value of the pseudo force, the magnitude of the pseudo force onto this is 5, mass of this and acceleration of this, that is 5 into 5, that is 25 Newton. So these are pseudo forces, 100 Newton onto this, 25 Newton onto this. Now he has not touched any real forces, that is T and mg, he has not touched it. He has drawn the forces. He has also taken into account the pseudo force also. So now he is competent to apply laws of motion. So he says, that is, now I wish to apply, that is, resultant force is equal to mass into acceleration. So he observes, that is, this block will be going down with the acceleration A in the downward direction. Let's make it here, A in the downward direction, and this block will be going up with acceleration A in the upward direction. So equation for this is going downwards. So what we can say is 200 plus 100 is 300 Newton is the downward direction, minus T, downward forces minus upward forces, the net force is equal to mass is 20 into acceleration is A, which we don't know. That is, this A is the acceleration of these blocks as seen by this person, not by that person. This A is the acceleration of these blocks as seen by this person. So 300 minus T is equal to 20 into A. Either you write it like this, or if you wish to stick to it, that is, upward direction vectors, you wish to take it as positive, downward direction you wish to take it as negative, and then if you directly wish to use F is equal to ma, then if we use this method this way, so downward forces is 200 plus 100, that is minus 300 in the downward direction. T is in the upward direction, so that will be positive. 300 Newton was in the downward direction, so that why downward is negative, so minus 300 plus T is equal to mass is 20 into acceleration in the downward direction, so that's why it should be negative, minus A. So it is minus 300 plus T is equal to minus 20A. If you multiply both the sides by minus 1, you will get it as 300 minus T is equal to 20 into A. That's the same equation you get. So it is one and the same thing. Wherever you feel, whatsoever way you feel comfortable, you can write that way. So this is accelerating down. So 300 minus T is equal to 20 into A. Equation for this is going down, accelerating down, this will accelerate up. So T, upward forces minus downward forces, 50 plus 25. 75 is equal to mass is 5 into acceleration is not known. If you add the two, minus T and plus T, they will get cancelled. 300 minus 75. So this makes 300 minus 75 is equal to 20 plus 5, 25 into A. This is 225 is equal to 25 into A. So A comes out to be 9 meter per second square. This is the same thing what we have got when we had taken this as initial reference frame, and when he was writing the equations, then the acceleration of these blocks with respect to the lift, that was the same thing. It had come out to be 9 meter per second square. So now if we have to find the acceleration of this block as seen by this person, that is, now let's use triangle of acceleration. We have to find the acceleration of this block, 5 kg block with respect to this person. So it is this plus this, that is acceleration of lift with respect to this person on the ground. What is that? That is plus 5 upwards. It is going upwards. So it is plus 5 meter per second square. What is the acceleration of this block with respect to lift? That is, it is going up 9 meter per second square. This person will see it going up with 9 meter per second square. Upwards is positive, so this is plus meter per second square. So acceleration of this as seen by this is side A plus side B. This is plus 5 plus 9. So plus 5 plus 9 is equal to plus 14 meter per second square. Is the acceleration of this as seen by this. If we wish to find the acceleration of this with respect to this, that is as seen by a person on the ground, so it is going to be plus 5, and this is in the down direction, minus 9. So it is going to be plus 5 plus minus 9, that is minus 4 meter per second square. That is, this person will see this block going down with an acceleration of 4 meter per second square. This is absolutely the same thing what we have got when we have taken our reference frame on the ground, that is initial reference frame.